This is section 8.1, the counting principle and permutations. We need to get a few vocabulary items out of the way first. The first one is the notation that we have for what's called the factorial. And it's an exclamation point, as you see here. And n factorial would be n times n minus 1 times n minus 2 until you run out. And 0 factorial is always 1. So those are things to remember. Now we can do this on our calculator, and I'm going to get the calculator up here real quick. All right, so I've put it in an older style instead of the brand new style, so let's see if we can find where we need to go. So I've written here math, and math is right here, and over to probability, and choose number 4. So you would want to have a number in there first, so let's do that. Let's go and say 5, and then go to math and over to probability and choose number 4. So now we have 5 factorial, which is 120. And if we think about it, that's 5 times 4 times 3 times 2 times 1. So 20 times 3 is 60, times 2 is 120. So it's a real quick way to do it. Now, if you have the newer style calculators, let me see if I can get that up here so we can see. It's a little bit, it'll be different in the permutations. I don't think it is in the factorial, so I think we're okay there. We'll come back to that. All right, the multiplication principle. So if n choices must be made, with m sub 1 ways to make choice 1, m sub 2 ways to make choice 2, etc., all the way to m sub n, then there are, and then you multiply the number of those ways together to get the entire sequence of choices. Now that sounds a little confusing, but let's think about this. So if you have 3 roads that go from A to B, so we could go this way, this way, this way. And then 2 roads that go from B to C. So we could do up here, we could do this way, we could do this way. How many different ways can you go from A to C? Well, there's 3 here, and there's 2 different ones when you choose from B to C. So there's 6 totally different ways to go. Now, a permutation is a number of n elements taken r at a time, and it has to do with factorials, so it is n factorial over n minus r factorial. We're probably not going to be doing these by hand. We'll be using our calculator. Example, in politics, 8 candidates are going for the Democratic nomination. In how many ways could voters choose first, second, and third? So we have 8 candidates, and we want to figure out how many ways could we choose first, second, and third out of those 8. So that means you're going to take 8 candidates 3 at a time. So 8 factorial over 8 minus 3 factorial. That's 8 factorial over 5 factorial. You could do it this way, the long way, but let's look on here. For permutations, that is under math and over to probability. Whoops. And number 2 is NPR. And it gives us the little boxes to fill in, so that makes it really nice. We'll go to 8 and then over and put 3 and enter. And that was really easy, and we got the 336. If you have the older style calculator, it looks a little different, so let's look at that. All right, so with this, you have to actually, you have to put your first number in first. So we'll put in 8, then we'll go to math, over to probability, and choose number 2. So you're saying 8 NPR, then you hit your 3. So you do it a little bit differently and hit it, and you still get that. So either way, you are able to use your calculator. All right, another example. Let's see, we went too far. A TV show has a panel of 4 women and 3 men. How many ways can the panelists be seated in rows of 7 chairs? So how many total people do we have? 7. So it's 7 people taken 7 at a time, because you're going to seat them in 7 chairs. So how many ways could we do that? 5,040. And in your calculator, if you're using the old way, this is what you do. If you have the newer calculator, you can just go choose NPR and put the numbers in the boxes. So you would have a little box, and you'd have P. I think, was it P that we had? I can't even remember now. And so we would put 7 and 7. And I'm not sure if that's NPR in the middle or what, but you just fill in the numbers. Okay? All right. Now, if the objects are not distinguishable, so we have, it's a little bit different. N factorial over N sub 1 factorial, N sub 2 factorial, N sub 3. So here's an example of that. How many ways can the letters in Mississippi be arranged? So if it doesn't matter, if they don't have to spell anything, so we have a total of 11 letters. We have 1 M, 4 I's, 4 S's, and 2 P's. So it's the total on top, 11 factorial, and then each of these factorials multiplied together on the bottom. There's not a way to do that other than in the calculator, other than when you get to this. You can do 11 factorial divided by, and you would want to put this in parentheses if you were going to do it there. Okay, I think that'll get us ready to start some problems and just get a taste of permutations. All right, so on number 1, it just says evaluate the expression permutation 12 things taken 6 at a time. You could do it this way and use factorials, or you can go to math probability for NPR and put in your numbers and you will get your answer. It's really quite simple. All right, number 2 just got a little bit different because you end up with some scientific notation, and I wanted you to see how you'll need to write it. So 39 things taken 18 at a time, and you get this number. So it says round to 4 decimal places. So we stop at the right there, and it's times 10 to the 26th. Right there. All right, number 3, 6 things taken 1 at a time would give you 6. You can do it in your calculator and make sure. All right, number 4, we're back to the counting principle. Pizza House offers 3 different salads, 7 different pizzas, and 6 different desserts. How many different 3-course meals can be ordered? Well, you got 3 salads times 7 pizzas times 6 desserts, 126. A man has 5 shirts and 3 ties. How many different shirt and tie arrangements can he wear? Well, that's 5 times 3 is 15. Okay. Find the number of distinguishable permutations of the letters in the word Kansas. All right, so we have a total of 6 letters. We have 1 K, 2 A's, 1 N, 2 S's. So 6 factorial over these numbers we just called out, factorial, and that is 180. Okay. Number 7, owner of a stereo store wants to advertise that he has many different sound systems. The store carries 10 different CD players, 7 different receivers, and 9 different speakers. How many different sound systems can he advertise if it takes 1 of each to make a sound system? Well, 10 times 7 times 9 is 630. That's that counting principle. A health inspector must visit 4 of 11 restaurants on Monday. In how many ways can she pick a first, second, third, and fourth restaurant to visit? Okay. So we've got 11 to do, and we are going to pick a first, second, third, fourth. So 11 things chosen 4 ways, 4 at a time. Gives you 7,920. Again, calculator will help you do that. In an experiment on social interaction, 4 people will sit in 4 seats in a row. In how many ways can this be done? So 4 people taken 4 at a time. Permutation 24. So I think that just gives us a little taste of permutations, and we can use our calculator or we can do it by hand. So I think that will get you going on 8-1.